the sampling length I have taken? See values, you can see R1 value. What I have done, all the peak value I have taken as a odd numbers. R1 is the peak, R5 is the peak, R2 is the peak, R4 is the peak, R3 is the peak. So I have taken peak values R3, R4, R2, R5, R1, right? Now the values, bottom lowest values, R6, R7, R8, R9, R10. So how many? 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. 5 maximum, 5 lowest. That difference we are taking. Okay. That is the, you can see the difference. We are taking the difference. We are taking the difference. So you can see 1 by 5. How many readings? 5 value. So 1 by 5 it is in the complete bracket. So if you write, you can write here also by 5 also. The complete 5 is completely outside. For R1 plus R2 plus R3 plus R4 plus R5, that is for the peak values, maximum values, minus difference is there. So R6 plus R7 plus R8 plus R9 plus R10 divided by 5. You can say this divided by 5, this divided by 5. That is why 5 has been taken in the bracket, right, outside. That is the 10 point, that's why name is there 10 point height method. Why name is there 10 point height? Because here in the complete sampling length we are taking 10 points. In that 10 point, 5 is the uppermost peak values and 5 points are the lower values. Okay, that difference will take. Okay. Now we have a form factor and bearing curve. What we have a form factor and bearing curve. Here we can say there are certain characteristics which may be used to evaluate the surface structure. That is can be done by the form factor or and bearing curve. Form factor is what you can see, the load carrying area of every surface is often much less than might be the thought. You can see this, that load carrying area, when you apply the load, suppose you are I am taking machining only, that is the tool is being contact with the workpiece. So load contact area, that is the load, that will be very small, right? So much less. This can be shown by the reference line, the form factor. You can see this is the load contact area, this part, right? Now the form factor is obtained by measuring the area of the material above the arbitrarily chosen baseline. That is the, you can see here you have taken here you have taken one baseline. So of the area above that, so the area above that is the form factor that is obtained by the measuring the area of the material above the arbitrarily chosen baseline in the section and the area enveloping the rectangle. This complete rectangle, okay, this shaded region will be in the form factor. You can see here we can calculate the degree of fullness, that is referred denoted by K, that is equal to the area of the metal, ratio of the area of the metal by divided by the area of enveloping rectangle, area of the metal divided by area of enveloping rectangle. That is the degree of emptiness is equal to Kp is equal to 1 minus K, that is the degree of fullness. So degree of emptiness is equal to 1 minus degree of fullness, right? Now bearing curve, you can say this, in that curve, that what have in this complete rectangle, this part, shaded part, has been taken for the consideration of form factor. Now for the bearing curve, you can say the bearing curve area, the bearing area curve is also called as the Abbott's. We can say the Abbott bearing curve. That is also called as a Abbott bearing curve. Okay, this is determined by adding the length A. We can see this length. I have taken one complete sampling length 1, 2 here I have taken. This Abbott length A, B, have this some where flaws will be there, and I will leave that. This complete I have taken. I have left this B. I have left this C. Here I have taken. I have left that, like this. Okay. Now you can say this is also Abbott. This is determined by adding the length A, B, C, etc. and depth. See here, what for A distance at X, again at B for Y, again at C for Z. For adding that depth also, that is the A what you have taken at what depth, B I have taken what depth, C I have taken what depth, like that. Below the reference line and indicates the percentage bearing area which becomes available as the crest area worn away. This figure indicates the method of determining the bearing curve. You can say In this way bearing curve can be determined, right? Now we have a conventional method for designing the surface finish. You can see these symbols, that is as per the IS 696 surface texture specified by indicating the following, that is the roughness value, RA value in mm. You can see this figure, this part is the machining method, symbols try to explain here. Okay, here sampling length, okay, here directional lay, this part, here roughness value in micrometer, machining allowance, how much machining by this one is the IS standard symbol we can say. Okay, here machining method, sampling length, directional lay, roughness value in micrometer, machining allowance. Okay, that is we can see here, that is the conventional method for designing surface finish. Here roughness value, RA value, machining allowance, okay, sampling length or the instrument cutoff length we can say, sampling length we can say, sampling length here we can say. Now machining production method, what is the production method you are using, which production, turning you are using, knurling, okay, what operation you are using, right? Direction of lay, so with this direction of lay you can say these are symbols, perpendicular, angular, multidirectional, circular, radial. Okay, you can see this example, the best milled operation is there, sampling length 2.5, right? Now roughness value in micrometer 6.3 micrometer. Now what is machining allowance, how much, 1.2. okay, now this one equal to means parallel direction lay is there, right? So with this is the standard and this is the one example I have shown, right? Now you can see this one, the triangle is there na, this was the triangle, this is the triangle, this had also some significance. What is the significance you see here? The surface roughness on drawing is represented with inverted triangles, that surface roughness will be represented with the inverted triangles, right? Now the symbol you can see here, no triangle, it is, if it is RA value is above 25, then we need to represent that. Now we will take one triangle, if it is RA value 8 to 25, if it is more than 25 micrometer, then no need to represent, okay. If it is for one triangle, it is there for 8 to 25 micrometer RA value. Now two triangle I will take for again less, 1.628, right? Now three triangle for 0.25 to 16, right? Now four triangle we will take if it is less than 0.025, okay, you have to remember this, okay. So in their exam they can ask some questions in relevant to diagrams they can give and they can ask the values, okay. Now we have a measurement of surface finish. So sir,